مرحبا. Okay, so this is the fourth session on functions. Let me recall quickly, where did we stop in the last session? We talked about bijections. Okay, remember that we have a function f from the set A to the set B, which is a bijection. Okay, let me recall quickly what is a bijection. Okay, first let's recall what is a function. First, A is a set and B is a set. A is and F is the function. We call A the domain of the function, B the codomain of the function, and the function is an assignment which assigns to every element in A one and only one element in B. Okay, so this is what is a function. It's an assignment, it's a rule, it's a machine which for every input element from A, it produces one and only one element in B. Okay, now we studied injective functions and surjective functions. Bijections are those functions which are both injective and surjective. So one, f is injective. What does it mean to be that f is injective? It means that if you choose different elements in A, in the domain, then their images are different. Okay, so how will we say this? If for every x1, for every x2 in the domain of A, okay, maybe let me say this. Okay, so if we say for every x1 in the domain of the function A, for every x2 in the domain again, if x1 is different from x2, then the function sends them to different images. Then f of x1 is not equal to f of x2. Okay, so this is injectivity. And 2, f is surjective. What does it mean that f is surjective? Okay, it means that every element in the codomain B has a pre-image. So for every B in B, we can find there exists some A in A such that the image of A is this B. Okay, so this is the, and a function is a bijection if it is both injective and surjective. This is the meaning of a bijection. Okay, now let us say some brilliant observation about bijections. Okay, so suppose f from A to B is a bijection. Okay, so let's draw the picture. This is the domain A, this is the domain B, and we have the function f, and let's say we choose some, okay, let me write it here, let B be in B. So choose any element in B. Let's call it small b. What do we know about this B? Look, first, since the function is bijective, it is surjective. And what does it mean it is surjective? It means there must be an element, it must have at least one pre-image. So there must be some element here A, okay, whose image is B. So this is the first observation. And the second observation, okay, maybe you may ask, maybe it has two. Let's say X also is a pre-image. But this can't happen. Why this can't happen? Because if it happens, then two different elements are sent to the same image, but we know the function is injective. It does not send two distinct elements to one image. Okay, so this can't happen. Okay, so this means, what does it mean? That, okay, this means that, let me write it in red, for every B in B, there is a unique A in A such that f of A is equal to B. Again, what happens if f is a bijection? and you choose any element in the codomain whatsoever, there must be a pre-image of it because it's surjective, and this pre-image is unique. There's no other because the function is injective. You see, this is a very nice property about bijections, and this will allow us to define a function from B to A. We call it the inverse, F inverse. Okay, so let me say this. So this is our concept of today, the inverse of a function. The inverse of a function. So this is definition. Again, inverses of functions are only exist only for bijections. So let f from A to B be a bijection. So this means it's injective and surjective. Suppose it's a bijection. Now we want to define what is the inverse of f. It's another function. So the inverse is a function denoted by f inverse. Its domain is B and codomain is A. Is the function, so again, now I want to define a function, so I need to tell you an assignment. Okay, is the function which assigns to every element, to every B in B, the unique A in A such that f of A is B. Okay, so notice here we define f inverse using f. Okay, so let's use this picture. So f inverse will be, again, f inverse will be a function from B to A. So this will be f inverse. This will be f inverse. Now, so what f inverse is a function from B to A, which means for every element here, say, let's say C, f inverse must assign an image in A, in the codomain now. But we know, since f is a bijection, there is here a unique element alpha such that f of alpha is C. Okay, since f of alpha of C, we define f inverse of C to be alpha. So let's use the red for the inverse now. So this f inverse will assign to C alpha and f inverse will assign to B A. Okay, so maybe I'll write it here. F inverse of B is A if and only if f of A is B. And the picture is as follows. Here is A, here is B. This is the function f. F assigns A to the element B, and f inverse, this is, this is the element B. And this is the function f, and now the function f inverse assigns A to B. Okay, I hope. So f is a function from A to B, f inverse is a function from B to A, and the image of B under f inverse is A, where A is the unique pre-image of B under f. Okay. So let's have an example. Okay, maybe I'll say a comment that if f inverse exists, which means if f is a bijection, we say f is invertible. Okay, let's have an example. Okay, look at this function f. Okay, this is the function f. Its domain has three elements, A, B, and C, its codomain has 3 elements as well, 1, 2, and 3, and it assigns A to 2, sorry, 2 to A, and the image of B is 3, and the image of C is 1. Now, can you quickly check that this is a bijection? Notice that 2 different elements here are assigned 2 different images, and every element in the codomain has a pre-image. The pre-image of 1 is C, the pre-image of 2 is A, the pre-image of 3 is B. Since F is a bijection, we expect F to have what? To have an inverse. So if we call this A, this set A, and this set B, then we expect F inverse. Okay, let me use another color for the inverse. Okay, we expect F inverse to be from B to A. Okay, so this is F inverse. B is the set of 1, 2, 3, and A is the set of A, B, C. Now, what is F inverse of 1? F inverse of 1 is the unique pre-image of 1 under F. So look at 1, the pre-image is C, and so F inverse will assign C to 1. Okay, now what's the image of 2 under F inverse? So F inverse of 2 is, say, let's call it X, if and only if F of X is 2. So look, which is the this means that it is X is the pre-image of 2 under F. This is 2, the pre-image of 2 under F is A. So this means that F inverse assign A as the image of 2. And now to find the image of 3 under F inverse, you want to find the pre-image of 3 under F. So here is 3, its pre-image is B, and so the image of 3 under F inverse is B. Okay, so this is the function F, and this is the function F inverse. Now let's have an example, another example. Okay, consider the successor function from Z to Z, the set of integers, where f of n is defined to be n plus 1. So for every integer in the domain, the function assigns the successor n plus 1, which is also an integer. Now find the inverse of f. Okay, first you need to check that f is bijective. And we did this previously. You can check it yourself that f is both injective and surjective. If you choose 2 different elements, their successors are different. And if you choose an element in Z here in the codomain, its predecessor is the pre-image. Okay, so f is bijective. Okay, it is bijective. Let's find a formula for the inverse. Now the inverse, f inverse of, will be a function again from Z to Z. Okay, let's choose some m. Okay, so suppose this is n and its image is m under f. Then since it's a bijective, then this is the unique pre-image, and we expect f inverse to send m to n. So this means f inverse of m is n. By definition, if and only if the image of n under f is m. So if and only if f of n is m. Okay. If and only if, what is f of n? The image of n under f is the successor. N plus 1 is m. And if and only if n is equal to m minus 1. So this means, therefore, the image of m under the inverse is n, but n is m minus 1. Okay. So what is the inverse function? It is the function which takes an integer as an input and produces its predecessor as an output. Okay, so maybe I can say let's take part of f, for example. If f sends 1 to 2, sends 2 to 3, sends 3 to 4, sends -5 to -5 plus 1, which is -4, and so on. Now, what's the role of f inverse? Say, let's start with 5. F inverse will send 5 to 5 minus 1 to 4, and 4 will be sent to 3. 2 will be sent by f inverse to 1. 0 will be sent by f inverse to -1. Okay, and so on. So this is the function, and this is its inverse. Okay, let's have another example. Consider the function, let's called also f, from the set of real numbers to the set of real numbers, where the image of a real number under f is its square. Okay. Now find, is f invertible? Is f invertible, which means does f has an inverse? Invertible. The answer is no, because in order for a function to have an inverse, it must be bijective. And to be bijective, you have to be injective and surjective. But clearly this function is not injective, no, because f is not injective. Why it is not injective? Because there are two different elements in the domain R which are sent to the same image. Okay, so since, say, 2 and -2 are in the domain, are in R, but f of 2 is equal to 2 squared, which is 4, and 4 is also equal to f of -2. So we have two different elements which have the same image 4. And this shows that it is not injective, so it's not bijective, and so it's not invertible. We can define an inverse for a function which is not a bijection. Okay, so the suggestion here is let's modify this function, modify the domain and the codomain of this function by getting rid of the negative numbers. Okay, so let's rewrite this example. So now let f be a function from the set of non-negative real numbers, so numbers which are bigger than or equal to 0, to numbers which are bigger than or equal to 0, real numbers, okay, where again it is the square function, where f of x is equal to x squared. Okay, now, so this is another example. Find f inverse. We want to find the inverse of the function f. Before we start finding the inverse, we need to check it's a bijection. So first, let's check that f is injective. Okay, which means let's prove that f is injective. Okay, so let x and y be two elements in the domain, and suppose that they have the same image. Suppose that f of x is equal to f of y. We will show that x must be equal to y. This is the meaning of injectivity. Either when you choose different elements, they have different images, or the contrapositive, which if the images are equal, the elements must be equal. Okay, so since f of x is equal to f of y, we get that what is f of x? It's x squared is equal to y squared. Now we manipulate this equation by subtracting y squared from both sides, so x squared minus y squared is equal to 0, and this is the difference between two squares, so this is x minus y. Okay, so this is true if and only if the following is true, is equal to 0, and these are the product of two real numbers, and the product is equal to 0, which means that either x, the first one is 0, or the second one is 0. Now if the first one is 0, then this means that x is equal to y, and this is what we want, right? So we assume that they have the same image, and we want to show they are the same element. Okay, or x is equal to negative y. But remember that both x and y are non-negative real numbers, and the only way where this can happen if x is equal to 0 is equal to y. So again, x is equal to y, and this shows that this function is injective. Again, how did we show it's injective? Because we chose any two elements in the domain. Okay, here are they, x and y, and we assume they have the same image. So we chose two elements and we assume they have the same image, and then we proved that they must be the same element. Okay, so it's impossible to assign, to have two different elements with the same image. Okay, so this shows injectivity. Now, 2, we want to show that it is surjective, f is surjective. What does it mean that f is surjective? So here is a copy of the domain, and here is the copy of the range. It means that if you choose any element here y, which means that y is a positive or a real number or a 0, we must find some x whose image is y. Okay, so let y be bigger than or equal to 0, real number, be in the codomain. Can you anticipate what will be x in the domain such that the image of x is y? Remember, what is the function? It squares the input. So I propose to have x, the pre-image, to be the square root of y. The square root of y, notice that it exists since y is non-negative. Okay. Now let's check that x is indeed the pre-image of y, so check. Let's see. F of x, what is f of x? It's the square of x. But what is x? It is the square root of y. And this is y. So this means for any y we choose in the codomain, we find a pre-image for it, namely the square root of it will be a pre-image of it. So this shows that f is surjective. Okay. This means that f is a bijection. So it's both bijection, it's both injective and surjective, and this means it has an inverse. So let's find a formula for the inverse. Okay, so remember, now consider f inverse, where f inverse will be from the codomain of f, which is non-negative real numbers, to the domain of f, which is also the same set. And notice that f inverse of y is equal to x, and maybe the picture would help. Okay, this is, say this is the function f. Okay, now if we choose an element here y, then we know since f is bijective, okay, since it's surjective, there must be some element here x whose image under f is y. And second, this x is unique, okay, because it's injective. And this, because x is unique, we define x to be the image of y under f inverse. Okay, so f inverse of y is x if and only if f of x is y. This is how we define the inverse, right? We defined f inverse of y to be x, where x, what is x? Is the unique image, the unique pre-image of y under f. Okay. Now, what is f of x? It's x squared is equal to y, and since both are non-negative, this means that x is the square root of y. Okay. Okay. Therefore, f inverse of y is x, but what is x? It is the square root of y. So this is the inverse function of f. It takes y as an input and produces its square root as an output. Okay. So let me for example, give a particular example about one input. Say, let's choose the number 3, say in the domain of f, then 3 will be sent by f to 3 squared, which is 9. And 9 will be sent by f inverse to 3. So this is by f inverse. Okay, so this is the end of this session.